All right, number 8 is pretty short and sweet. They ask, which of the following is not a group? Which of the following is not a group? And so in order to answer that, we need to know what the properties of a group is. So a group G under an operation, let's call it star, has the following properties. Number 1, excuse the train in the background, it's never ending. All right, number 1, what is the first property? There exists an identity under the operation. So for G, so there exists E in G such that G times G star E equals E star G equals G for all G and big G. Okay, so that's called the identity. Now second property, for all G and G, for all little g and big G, there exists a G inverse that is also in G such that G star G inverse equals G inverse G inverse star G, which is equal to the identity. Okay, those are the first two properties. The third property is that for all G and H, not K, H and G, the following is true. For all G, H, and K and G, the following is true. G star H star K equals. So the associative property is what I'm writing now. The associative property. Okay. The associative property. And then lastly, for a group, the last property is that G star H is in G, meaning it's closed under the operation. So you can't perform an operation on two elements of the group and get an element that is outside of the group. Now, those are the 4 properties necessary in order for it to be a group. Now, if it's an Albanian group, there is a 5th property. If it's an Albanian group, so these 4 are the only ones you need in order for it to be a group. If it's an Albanian group, then it has to be commutative. So G star H has to equal H star G for an Albanian group. But number 8 just asks which is not a group. Which is not a group. That's all number 8 is concerned with. And so the one that is not a group is going to be the option that says this option is the one that's not a group. And then I'll show you why it is not a group. The others are, and you can check that the others are by just checking that they satisfy the 4 properties that I just gave. I don't want to go through it because I want this video to be a certain length. I don't want it to be too long. All right. So this the one that is not a group. This one's not a group, and I'll show you why. So the non-zero integers under multiplication. I'll show you the property that they fail. Under multiplication, so the group is the non-zero integers under multiplication. So that's the group. G is equal to that, right? So remember I said it has to be closed under the operate. No, that's not the problem. The problem is when it comes to the identity. For this group G, our identity E is equal to 1. 1 is our identity, right? Now, in order for it to be a group, every element must have its inverse that is in the group, meaning every element in this group, so every little g in G, has to have an H in G, such that G times H, because our operation in this case is multiplication, so G times H must be equal to 1, and both H and G must be in G. That's not true here. The inverse, let's take any integer. Let's take 5, right? 5. The inverse of 5 is 1 over 5. 1 over 5 is not in the integers. And that's why this one is not a group.